Welcome to qnawire.
This is problem number 45 of the Stewart Calculus 8th edition, section 2.8. Graph the function f of x equals x plus the square root of the absolute value of x. Zoom in repeatedly, first toward the point -1, 0, and then toward the origin. What is different about the behavior of f in the vicinity of these 2 points? What do you conclude about the differentiability of f? So we take a look at the function here, plotted using a graphing calculator or any plotter, x plus the square root of the absolute value of x. And here we're looking at the 2 points in question, -1, 0, and the origin 0, 0. The behavior of f is different at each of these 2 points. Although it's continuous at every point here, we see the function is definitely continuous, as in any number within this domain uh, is part of the domain of the function. So -1 will give an answer of 0, as will x equals 0. So this is a continuous function. However, the behavior is different at -1, 0 because it is a smooth function. The function does not abruptly change, doesn't have a corner or a kink, and it is differentiable, and it is uh, continuous, and it does not have a vertical tangent. So none of the differentiability restrictions apply. Therefore, the function is differentiable at -1, 0. However, However, at the origin, the behavior of the function is different. It has this curve towards the origin and then away from the origin. This can be described as either having a vertical tangent at x equals 0 or what we call a cusp. But essentially, what we have is we have a negative um, derivatives, negative slopes of tangent lines to the left of x equals 0, and then positive tangent lines, positively sloped tangent lines to the right of x equals 0. Therefore, it is not differentiable at x equals 0 for the reason that this function curves in its cusp to here at x equals to 0. So it is differentiable at -1, 0, but the function f is not differentiable at x equals 0 or at the origin.